Now we will do numericals related to consolidation. So in the first example, the consolidation test was done and the load was changed from 50 kilonewton per meter square to 100 kilonewton per meter square, and as a result the void ratio changed from 0.7 to 0.65. So determine the coefficient of volume decrease, that is mv, and compression index, that is cc. So we have value of E naught here as 0.70. That was initial reading, and once the load was increased, so this is corresponding to load or stress of 50 kilonewton per meter square. So once the load was increased to 100 kilonewton per meter square, the void ratio decreased to 0.65. So we know that AV is equal to delta E over delta sigma, alright, or as we read it as delta E over delta P, so they mean the same thing. So delta E over delta P, so delta is change in void ratio, so 0.70 minus 0.65 over change in stress, that is 100 minus 50. So it is giving us AV or coefficient of compressibility of 0.001 meter square per kilonewton, and we know that mv is equal to AV over 1 plus E naught. So AV we have just achieved from here, and E naught is 0.70. all right, so this was E naught. So we place in the values and we get a value of 5.88 10 to the minus 4 meter square per kilonewton. Lastly, we'll find out the compression index, and we know that formula for compression index is cc is equal to delta E over delta log sigma dash, or simply log 100 minus log 50. So plug in the values and we will achieve cc of 0.166. So now we move to the second example. It is a little bit in not very clear syntax, but I'll try to write it here if anything is ambiguous. So it says that a consolidation test was performed on a sample with initial dimension of h is equal to 20 millimeter. So this is the initial soil specimen. So initial height of the specimen was 20 millimeter and the diameter was 63 millimeters. So this was 63 millimeter. So at the end of the test, the sample height was, so it was reduced to 13.3 millimeter, and the oven dry weight of the soil was 783 grams. So WS of or dry soil solid was 783 grams at the end of the test. So we have to use GS of 2.66. okay, so what data do we need to find out? We need to find out the initial void ratio E naught, that is relating to the initial condition here, and we need to find out EF, final void ratio, that is relating to this second stage, and total sample strain or EF we can also represent it by delta, and it should be equal to H2 minus H1 over original height H2. So this is strain, so this is easily found. So alright, so to find out E naught, so the first step is to use the formula of height of solids. So height of solids HS is equal to WS over GS gamma W into area of the soil specimen. So WS, weight of soil solid, is 783 grams. GS of the soil is 2.66, and gamma W, because we are using units of gram per centimeter, so that is 1 gram per centimeter cube, and the area of the specimen is equal to pi by 4 d square, and d was 63 millimeters. So it will give us a value of, let me bring my screen here, it will give me a value of 31.172 millimeter square. So let me write it here, that area of the soil specimen is pi by 4 d square and d was 63 millimeter, so it gave me a value of 31.172 millimeter square. Alright, so From this, HS or height of solids is coming to be 0.9443 centimeters. So sorry, this is also centimeter square. Please do this correction. So HS. So formula for E naught is H1 minus HS over HS, where H1 is this initial height of the soil specimen. Okay, so now we put in the values. So H1 is 20 minus HS is 0.9443 over 0.9443. So this is giving me an E naught of 1.12. So this was E naught. Okay, and then similarly we will find out EF. Okay, so first of all find out we'll do the easier part, that is strain, that is simply equal to H1 minus H2 over H1. So H1 is 20 millimeter minus 13.3 over 20. So this is EF for strain, so we can find out its value from here. So EF is coming to be, let's see from here, 33.5%. right, and lastly the last part is finding out EF. So EF is equal to, it would be second height H2 minus height of soil solids over height of soil solids. So H2 was 13.3 minus, and HS was 0.9943 over 0.9943. So the answer is 0.408. So this is EF. Now you have to remember these equations, EF and E naught, using height of soil solids method. And let me highlight that for you, this equation as well as this equation and also this equation. Okay, so we will talk about the derivation of this height of soil solid method in a separate video. All right, thank you.